actually provision an RDS instance and creating and then dealing with it in terms of connecting and you don't have to, as an end user, you don't have to worry about anything, right? As a developer, you don't have to worry about any complexities with respect to managing the underlying hardware, the instance on which the RDS is running, patching, maintenance, nothing of that sort, right? You just go, you get a console. Using the console, you provision it, and you're all set. But you just need to start working with it. That's it. And similarly, even DynamoDB, you all learned, how a NoSQL actually works, right? I mean, it's not a fixed schema, right? You can actually insert anything in a row, in a table, correct? And you have something called a partition key, and you have something called a sort key, and you can have variable length, variable types for your key value pairs that you store within the table, right? So it's an entirely new concept. I mean, unlike how we typically do it in a traditional databases or DBMs, where the schema is well defined and you won't be able to violate the schema. In case if you want to be flexible, you won't be able to do it in a flexible fashion. You won't be able to store data in a flexible fashion, right? So that's where NoSQL databases really help us. And that's how NoSQL databases are able to scale, right? I mean, there's no limit. You can store as much amount of data as you want. Unlike relational databases have got their inherent limits in terms of the amount of data that it can store and scale, correct? And you can actually look for those limits for those respective databases. Like for example, for SQL Server, if you see, there will be a limit. SQL Server will not be able to store and process beyond a certain point of data volume. Okay, all right. So let's get started with a new topic today. In fact, I was just thinking that since we have that momentum of building a database and we have learned RDS, I don't want to break that momentum. So I've just made a slight modification in the curriculum a bit. So what I've done is I've gone into let's continue that momentum and let's learn about load balancers. Let's learn about auto scaling, the EC2 auto scaling, and then let's also do a project on all these topics, right? Where you use EC2, RDS, load balancers, and auto scaling, and you basically build a complete fault tolerant WordPress website. Okay, WordPress is it's a content management system, right? It's an open source content management system. You can use it for free. A lot of websites are based on WordPress, right? So we can actually build a complete application, and you would actually get a complete 360-degree view of how to deploy an application end to end, which has got a front-end application server component running on Apache, and which uses MySQL, RDS MySQL as the backend, right? And how do we make it in a multi-AZ model? How do we deploy it in a multi-AZ model? All of that, right? So we'll complete that, and then we'll get into the management, right? I mean, that's where I'm going to teach you about how to use the management tools, how to use the CLI, how to use a Python SDK, right? And also give you a bit of an introduction into Python, right? So that's basically, we are fast forwarding by about 3 classes, and then we'll catch up with these 3 classes after we are done with our WordPress demo, WordPress project. Okay, I'll just quickly share my screen and show you what I'm referring to. Just give me a second. Yeah, so let me just share my screen, show you the change that I've made in the curriculum a bit. Okay, so we have completed this databases on AWS, correct? And we have also learned S3, Cloudfront. All of these are going to be useful when we do the project. So I don't want to take this detour for these three classes. So we'll just shift these three classes below. Okay, I'm just going to do this. I'm going to do this. Okay. So, yeah, this is the change that I'm going to do. So we'll start with load balancers, health checks, and auto scaling. And we'll also do, this is the project that we're all going to do. This is project number 1, right? And then after that, this is going to be project number 2. So these are the 2 projects that we're going to do. So it's going to be quite interesting. And in fact, last year, a lot of people benefited out of this and they were able to complete the projects, correct? And don't worry, these are all going to be within the boundaries of your free tier, right? So we're not going to exceed the free tier to complete these projects. So very powerful, but still simple projects, okay? So let's start with load balancers, right? So yesterday we learned about, over the last few days, we learned about S3, right? S3 is a powerful storage service where you can actually store any kind of objects and you'll be able to, perform API operations on those objects, and you'll also be able to use S3 as a place to host your static websites. And then we learned about Cloudfront. Cloudfront is a service that brings content delivery network, where you can use Cloudfront to cache your objects across the global edge locations so that end user experience is enhanced. Correct. So then we learned about databases of RDS, Aurora, and DynamoDB. So RDS is a relational database service where you can choose one of those 5 engines and you can stand up a complete database instance, which is a AWS managed service where you don't have to worry about the underlying infrastructure. You only worry about the database engine, right? Nothing else. And you build your database on top of it, such as define your schema. And then we learned about NoSQL. So now both RDS, MySQL, and the DynamoDB that we used are going to be used in our projects. Okay, so that's the reason I was focusing on these 2. So now when we actually build a fault-tolerant WordPress website, it's going to be based on RDS, MySQL. And when we do the second project of building a serverless web page with Lambda API Gateway and DynamoDB, we're going to actually use DynamoDB. Okay. Okay. All right. Let's move to load balancers. So okay. So what is a load balancer? Has anyone learned about load balancers, or at least know about load balancers? What is a load balancer? Can somebody speak about it? If you have worked with it, or if you have at least.
It controls the load going to the server.
Okay. What else? Thanks for that. What else?
Based on the traffic load, it will either decrease or increase the CPU servers.
No, not really. That is not a load balancer's job. What does a load balancer do? Okay, so it's like this, correct? So you are there's a event that's happening, right? So there's an exhibition that's happening. Okay, that's a huge exhibition, and there's going to be some sort of a security screening at the entrance of the exhibition grounds. Okay. So now there are going to be several counters, right? So several security check counters. There's not only one single counter, right? There are going to be several security check counters. And the reason why you have those number of security counters is that, if you just have a single counter, then that becomes a bottleneck. That's going to be a choking point, and people who come in are going to wait for a longer time. And entering into the exhibition is going to be a tough job, right? So that's the reason you have multiple counters, and it's basically going to parallelize the entire security screening process, correct? Load balancer works in a very similar fashion. Correct? So load balancer, what load balancer does is it parallelizes the request that is coming to an application. Okay, it can be a HTTP request or it can be a TCP request, doesn't matter. But load balancer is a device, as the name says, it balances the load. Okay, say you have 4 web servers. Okay, and these 4 web servers are actually serving content back to its end users, right? So why do you need a 4 web servers? Why can't you just do one single web server? Because having a single web server has several disadvantages. Couple of important ones are, number one, it will be a single point of failure. What if the web server crashes? You will be left with nothing until you build a replacement for that web server which crashed. That is the first disadvantage. The second disadvantage is when there is an increased load and when there are more users coming in, that single web server, however big it is, may not be able to serve the traffic because it may already be saturated with respect to the resource utilization such as CPU and memory. Okay, so from that standpoint, you will have different web servers and you'll have multiple web servers serving the same web traffic, connecting to the same data source. But each one is actually going to balance the load. Okay, it's like this, right? I mean, there is a event that is going to happen and you have to prepare for the event. There are going to be multiple people, who are going to share the load, right? Because it's not going to be possible to just pull off an event by a single person, correct? So now there are going to be multiple people, like say assume 10 people are working on, arranging something for an event, correct? Or maybe doing the decorations, right? But somebody has to basically orchestrate all of them, right? Because somebody has to tell them that, okay, you do this, you do that, you pick up this corner, you pick up this corner, right? So that's the job of a load balancer. So load balancer basically interfaces all these 10 people, assigning them jobs, right? And then getting it completed, right? So that's the job of a load balancer. It's in this case, a load balancer is a service that is, that's, in fact, there are several open source load balancers, right? Every cloud service has got a load balancer service, load balancing service, right? So the primary job of a load balancer is to distribute the network traffic to improve application scalability. What is scalability? Scale is, if say there are 10 users who are accessing the application and the response time of the application is say few milliseconds, right? So let's say 100 milliseconds. Now, if those 10 users grow to say 100 users, the response time should not degrade. Okay, it should still be 100 milliseconds. It shouldn't become 500 milliseconds, right? If it becomes 500 milliseconds, then you're not architecting your application and you're not using the right mechanism to balance the workload. Okay, so now if the user count increases from 10 to 100, the load balancer's job is to ensure that it distributes the load to all the backend nodes, all the backend servers in such a way that all the backend nodes, all the web servers, application servers have got some work to do instead of hogging one single web server or application server. Okay, so that's the primary job of a load balancer. So let's just go. Yeah, so let's quickly look at this video. And there are different types of load balancers that are available in AWS, something called a network load balancer, and something called an application load balancer. There used to be a load balancer called classic load balancer, but that's deprecated, that's no longer in use. So instead, AWS has engineered and built 2 types of load balancers. One is a network load balancer, which can handle traffic at a TCP level, at a TCP protocol. The other one is called application load balancer, which operates at layer 7. What is layer 7 in TCP IP?
Application layer.
Application layer. Perfect. Yeah. So the application load balancer operates at layer 7, which is at an application layer, which only handles HTTP, HTTPS. Right? It does not handle a TCP. The TCP is it's much more lower, right? It's a layer 4. What is layer 4?
Transport layer.
Transport layer. Perfect. Yeah. So TCP works at a transport layer. HTTP, HTTPS works at application layer, which is layer 7. Okay, perfect. So let's just quickly watch this video. Is this guy not loading?
Elastic load balancing improves an application's availability by distributing incoming traffic between two or more Amazon Elastic Compute Cloud or Amazon EC2 instances. Elastic load balancing routinely checks the health of each load-balanced Amazon EC2 instance. If Elastic load balancing finds an unhealthy instance, it stops sending traffic to the instance and reroutes traffic to healthy instances. To get the most out of this video, you should already have an account with Amazon Web Services, have signed up for Amazon EC2, and have created at least 2 Amazon EC2 instances with active HTTP servers. Important: the load balancer you're about to launch will be live and not running in a sandbox. This means that you will incur the standard Elastic load balancing usage fees for the load balancer until you terminate it. The total charges will be minimal, typically less than $1 if you complete the exercise described here in one sitting and delete your load balancer when you're finished. For more information about Elastic load balancing usage rates, go to the Elastic Load Balancing product page. Defining a load balancer. To define a load balancer in the AWS Management Console, navigate to the EC2 tab. Click Load Balancers in the navigation pane. The console displays the Load Balancers pane. Click Create Load Balancers. The Define Load Balancer page of the Create a New Load Balancer wizard opens. Enter a name for your load balancer. Leave the listener
I'm just going to
configuration.
stop this video. This pretty old looks like. Okay, so let's just go and get started with the load balancer. Okay. All right. So if you go here to Elastic load balancing, the product documentation. Yeah. All right. I'll just go to the user guide. Right. So Elastic load balancing automatically distributes your incoming traffic across multiple targets, such as EC2 instances, containers, and IP addresses. Right. In fact, it can also send it to your on-premise virtual machines, provided you have connectivity between AWS and on-premise in one or more availability zones. It monitors the health of its registered targets, routes traffic only to healthy targets. ELB, it's called ELB, okay? The product name is called ELB. ELB scales your load balancer as your incoming traffic changes over time. It can automatically scale to the vast majority of workloads, right? So that's the reason it's called elastic in nature, right? So now you don't have to size your load balancer. It automatically resizes, because at the end of the day, it's a compute component which will take the traffic, receive the traffic, and send the traffic to the backend nodes, correct? So now, obviously, when traffic increases, say from 100 users to 1 million users, the load balancer itself should be capable of handling that 1 million user traffic. Yeah.
Sir, you said load balancer directs the traffic towards the healthy machines, right? So, what parameters does a load balancer consider to classify a server as healthy or not healthy?
You are going to get an answer to that shortly.
Okay, thank you.
Okay, I'm going to come to that, but I'm just trying to explain, what are the fundamentals for, people who are not aware of what a load balancer is. Okay, people who are not conceptually clear about what a load balancer is. I'm just trying to explain that concept. More specifics, I'll come to that shortly. So please hang on there. Yeah, stay with me.
Yes, sir, thank you.
Okay. So what a load balancer does is it basically takes the traffic and it sends it to the backend web servers or application servers. Okay, so now the reason why it is elastic in nature is it will be able to seamlessly scale itself, right? I mean, it will be able to handle 10 users or handle 10,000 users, handle 10 requests per second or 10 million requests per second without any issues, right? It can scale behind the scenes transparently, right? Without the end users knowing that, there is a service like this sitting in front of my application servers, and it is able to scale according to the traffic that it receives. Okay, so that's the benefit, and that's why it's a managed service. So that's why it's called elastic load balancing, right? So it's because it's elastic in nature. It can support 10 users in the first 5 minutes, and after that, in the next 5 minutes, it can support 10,000 users also. Okay, it can automatically scale. So now, when you provision load balancers, you're not going to specify that my load balancer will support 10 users or 10,000 users. There's no way you'll be able to specify that. All that is intrinsically taken care by the load balancer. So now, what are the benefits of load balancer? It distributes workloads across multiple compute instances, such as virtual servers. And the primary job of a load balancer is to increase the availability and fault tolerance of your application. Right? So availability, right? How can it improve the availability of your application? Because you're not relying only on one single web server or application server to serve your application, right? You provision multiple smaller instances instead of provisioning one single large instance, and depending on that single instance to do the job. It will do the job as long as it is alive, correct? But what if it goes? What if it dies? So then you're completely left high and dry, correct? So that's where it is always wise to split the job across multiple smaller EC2 instances, because the cost is going to be one and the same at the end of the day, right? Whether you provision one, T2.x large, or you provision 4 T2.micros, the cost is going to be one and the same. So, but if you just provision one T2.x large, and you deploy your application and it supports say 100 users, then what happens is if that single instance goes down, then you will face an outage for your application, correct? Whereas if you split that into 4 T2.micros, each T2.micro can handle about 25 users. Okay, so that way you have 25, 25, 25, 25, 100 users. On the whole, you are able to support up to 100 users. So now what happens is if one T2.micro goes down, it's not going to impact all the 100 users, correct? It's probably going to impact a few users, right? Then what it does is it automatically, again, it's not going to impact anybody, because what the load balancer does is it automatically takes that unhealthy instance out of my cluster, and then it's going to reroute the traffic to the rest of the healthy instances, right? So that way you're not causing any outage to your application, and you're not causing any availability issues to your application. Okay. And what you can do is you can add or remove compute instances from your load balancer as your needs change without disrupting the overall flow of the request to your applications. So while the application is running, you can add any number of instances, or you can remove instances from your load balancer. It's not going to impact the way your end users are actually accessing it, right? The load balancer is intelligent enough and it's smart enough to sense that a new node has come, and it has to start sending traffic to the new node, right? And then it maintains some sort of a stickiness with that node as well. So that's called sticky sessions and things like that. Okay, so how do you access ELB? Through management console. You have CLI, you have SDK, and you have query APIs as well. Okay, and there's also a pricing that. Okay, so how load balancers work? Okay, so now there are 4 different types of load balancers, but the 2 that we will be interested in are application and network. Gateway, just ignore it for now. That's a different thing. That's an advanced topic. Classic is getting deprecated. Okay, and you don't need a classic load balancer any longer. So now what load balancers does is, let me just do a small whiteboarding, right? So if you have your VPC, which is our classic red box, you've got multiple availability zones. Okay, availability zone 1 on the left side, availability zone 2 on the right side. You have two subnets. This is subnet 1, this is subnet 2. It can either be public subnet or it can be private subnets, because load balancers can also be public or private, right? I mean, you can provision a load balancer in a public subnet. So load balancer will have a public IP address, and it can also send traffic to private EC2 instances. Okay, so usually the pattern is, in the public subnet, you don't put any EC2 instances. Okay, you only provision a load balancer in the public subnet, so that public subnet gives your load balancer a public IP address. So none of your instances, the actual EC2 instances which are serving your web content, such as your application, is not exposed on a public subnet. They are behind in a private subnet. So any traffic that has to come through load balancer only, right? Because the load balancer is the guy, who's actually managing it. If you want, you can have multiple private subnets and multiple availability zones, and you can spread this EC2 web servers across multiple availability zones so that you have a better high availability. Okay, anyways, so now you have two availability zones, and what the load balancer does is, as the traffic hits it, it actually sends the traffic to the instances that are in my backend. Okay, in this case, both my instances, EC2 instances, are in a private subnet. I'm not exposing it on public, right? You can use the same hello world example that we created earlier, right? Where we created the Apache web server, Apache HTTPD server, and then we deployed a simple index.html which says hello world, correct? So we're going to do the same thing. So what the load balancer does is, it sends the traffic to both the nodes, right? How does it send it? So it uses certain algorithms. Okay, it's called a round robin algorithm, right? So now what the round robin algorithm does is, say, for example, let's go back to our example of, there's an event, and there are 10 people who are actually decorating the hall for that event, right? So now each person has taken one corner of the hall to decorate it, correct? So what the orchestrator, or the whoever is the manager, will do is to allocate tasks to all the 10 people, correct? And when a person completes the task, correct, when a new set of tasks comes, he will again go and allocate it to all the 10 people, right, in a round robin fashion, right? So again, 10 more tasks are coming, 10 more decoration items are coming. So what he will do is, he will hand over each one to one person in a round robin fashion, and then he will ask them to go ahead and start decorating the hall, correct? So here also it does the same thing. The first request, it sends it to first web server. Second request, it sends it to the second web server. Third, it sends it to the first. Fourth, to this one. Next, to the first server. So every alternate request, it sends to each web server. So that way, if say there are total 100 requests coming, 50 goes to this guy, 50 goes to this guy. If you have one more web server, then you will have 33, 33, 34 going to all the three servers. If you have four web servers, then you will have 25, 25, 25 going to each web server. So that's the way the load balancer balances the traffic across all the available web servers, or across all the available servers behind. Okay, that's the job of web server load balancers.
Sir, that load balancers, minimum how many servers are required?
You can have zero also. If you have zero servers, then nothing will be served. But you can have one, minimum one. But that's not the intent, right? You don't want to just put one server behind the load balancer, right? You want to at least put minimum two servers behind the load balancer, so that if one dies, the other one is available.
Yes,
But
and round robin, sir. Actually, it's a round robin, sir. Minimum, I think minimum 3 servers are required, right?
no, not
or 2 servers.
No, not necessary. Not necessary. In ELB, that's not the case. You can also have a single web server, single server in the load balancer. So it will simply send all the requests to that single server. When you have more than one server, then it sends it in the round robin fashion. But it's not necessary that you need to have a 3 servers minimum in order to do your round robin algorithm. That's not the case here. Okay. Yeah. All right. So that's where, you have, okay, so if you see this, right, there's something called cross-zone load balancing, but that's an advanced topic. I'm not going to go into that. Just leave it. Yeah. So if you see, these are some of the routing algorithms that the load balancers use, right? It evaluates the listener rules. There's something called listener rules. We'll learn about the listener rules shortly. Okay. The default routing algorithm is round robin. So it uses round robin as the default algorithm. Routing is performed independently for each target group. Okay, that's fine. Target groups, I'll teach you when we come to that. Okay. You can just ignore all of this, right? I mean, that's okay. You can just read about this later. But for the sake of our lab and for the sake of our understanding, so far you have understood that a load balancer is a device that will balance the load across multiple different targets. So now each one of these EC2 instances is called a target. And the targets can either be EC2 instances, or it can be containers, or it can even be IP addresses. Okay, when you containerize your entire application using Dockers, and when you deploy it in ECS or EKS, you can also front-end it by a load balancer. Okay, and load balancer basically uses round robin algorithm. There are other algorithms as well, but the default one is round robin, where it actually sends requests to alternating requests to each web server. So that way it balances the load across all the servers that are behind the load balancer.
Sir, before ALB, we'll be having internet gateway, sir.
Sorry, before ALB,
We will having internet gateway, sir.
It is not necessary, as I said, right? I mean, like how you provision EC2 instances, you can provision an EC2 instance in either a private subnet or a public subnet, correct? And when you provision a EC2 instance in a private subnet, will it have a gateway, internet gateway?
No, sir. Only for public.
No, right? Yeah, exactly. So similarly for load balancer also, you can either provision it in a public subnet or a private subnet. If you provision a load balancer in a private subnet, it will not have an internet gateway. Whereas if you provision it in a public subnet, it will have internet gateway and it will have an IP address, a static IP address allocated to it.
Okay.
It will have a public IP address allocated to it. So that, because you have to provision a load balancer so that your users from the internet will be able to access the service, right? If it is an internal, see, there are two types of applications, either an intranet application or an internet application. Intranet application is only within the network. Whereas if I have a network, I have an office, and so the application is accessible only from within my office, right? Whereas internet application is not like that, right? It's exposed over the internet. Anyone will be able to access my internet application. So now if you want to expose an application and behind a load balancer on internet, then you have to provision the load balancer on the public subnet. If you want a load balancer just for an intranet application where it will be accessed only by my internal users, then it will be on the private subnet. You can choose it.
Okay, sir.
Okay, fair enough. So what we will do is we'll just
make use of route table rights.
Sorry, one by one.
It will make use of route table rights to direct the traffic.
Yes, yes. Route table will anyways be used. Okay. I mean, so because your load balancer, when you provision a load balancer, it is like an EC2 instance, correct? Which will have a private IP address, a public IP address. So any private IP address that you provision or any resource that you provision within the VPC is routable, correct? Through the route table. So the same thing applies for load balancer also. Okay. See, imagine load balancer is like a EC2 instance only, nothing more than an EC2 instance, but it has got some special properties. That's it. Okay. What was the other question? There was someone else who was asking a question. Okay. All right. I'm just going to move ahead. So now how do you access load balancer? you go to the EC2 console. Okay. So out there in the EC2 console, you will see the EC2 instances and all of that. But as you come down, you have load balancers. Okay, so these are the load balancers that are there. Okay, I don't have any load balancers right now in my account. So what I can do is I can first start by creating a load balancer. Okay, I'm just going to go create a new load balancer. Okay, by the way, is load balancer covered under free tier? Did somebody check?
Yes, sir. Yes, sir.
Yes, sir.
750 hours, sir.
750
750 hours.
hours.
750 hours. Okay, perfect. Which one? ALB, is it? No, where is it covered? Where is it covered? Okay, here you have it here. Yeah, here. Okay. So 750 hours of elastic load balancing per month shared between classic and application. So here network is not covered, but application is covered. 750 per month, so 15 GB of data processing for classic load balancers, 15 LCUs for application load balancers. Okay, perfect. So it's covered in free tier. Okay, so earlier it was not, but okay, all right. So when you click on create a new load balancer, then you have to select the load balancer type, right? So you have these three different types of load balancers, and you'll also have a fourth one called classic load balancer. AWS will be retiring the EC2 Classic network on August 15, 2022, which means that the Classic load balancer will go away on August 15th, 2022. So let's ignore this, and this is no longer being used by customers, and we also don't recommend customers to use a classic load balancer because it's an old generation which does not have so many features. And if you want feature rich, and if you want to basically do a layer 7 load balancing, then you have to use an ALB. As the name says, it is application load balancer, which is layer 7. Okay, what it does is it only handles HTTP and HTTPS. Okay, it can either send it to a EC2 instance, or it can send it to a container, or it can send it to a Lambda function. Okay, Lambda function, we'll learn about it next week. Right? So when we actually get to the serverless, we'll learn about Lambda functions. But for now, just understand that it only deals at a layer 7. And if you are building applications that use the modern paradigms such as microservices, right, API gateway and things like that, right, APIs and the modern way of building applications, then naturally you will end up using an application load balancer. Okay, so now there is also another type of load balancer called network load balancer. So the network load balancer, what it does is it basically operates at a layer 4, which is the transport layer. So the protocols that are used at the transport layer are TCP, UDP, and TLS. Okay, TLS is basically the 443, right? HTTP is at the TCP layer. So and again, you can send it to a TCP traffic to either an EC2 instance or to a container or any server, which is actually listening on TCP, right? It's not listening on HTTP, rather it's listening on a TCP port. You'll be able to send it, and both of this actually run within the VPC. Both ALB and NLB runs within the VPC. So now, if you need ultra fast performance, okay, then usually you go for a network load balancer because it operates at a slightly lower level. What ALB does is, since it operates at layer 7 application layer, it actually takes each request, it intercepts each request, and then it adds a few headers to the request, and then it sends the request as per the rules that are defined within the load balancer. It evaluates those rules, and then it sends it to the backend target. So due to this additional operation, there is a little bit of an overhead that is associated with each request time. So that's the reason application load balancers are slightly slower than network load balancer, but whereas network load balancer doesn't have that overhead. So it simply passes through the request as it comes. It simply takes the request and it passes through that request to the backend target at the TCP protocol layer. That's the reason it is ultra fast performance. If you need applications that can work on TCP and which needs more performance, then you go for an NLB, which doesn't mean that, ALB does not give that high performance. ALB also gives that high performance, but it comes with a slightly smaller cost of additional time it takes to intercept the request. Okay, that's the difference between an ALB and NLB. Gateway load balancer, just ignore for now, because that's a more advanced topic, and you need to understand, how firewalls work and how appliances work. That's beyond the scope of this. So let's ignore gateway load balancer for now. Okay. When you are when you get interviewed, you'll basically get interviewed on these two topics, either an application load balancer or a network load balancer. Okay, now let's go ahead and create an application load balancer, right? So just click on create. Now, good that we check that it's available as part of the free tier. So we can go ahead and use it without any worries. Okay, so just give a name to this load balancer. Just say that my ALB. Okay, I'm just giving just a name to my load balancer called my ALB. So here you can either make it an internet facing or an internal facing. As I said, applications can either be intranet or internet, correct? It can either face the internet or it can just simply stay within the network, which are internal applications. So now if you just need an internal load balancer, you can just simply go for an internal load balancer. But if you have an internet application, then you go for an internet facing. So now we are going to provision an internet facing load balancer. And load balancers also support IPv6, but I mean, we'll just go with simply IPv4 for now. And VPC, right? Which VPC you want your load balancer to stay, right? I mean, I want my VPC, correct? Red box. That's where my load balancer needs to sit, right? That's where my application load balancer needs to sit, right? So I'm going to select my VPC. Okay, and which all availability zones I want my load balancer to actually spread, correct? Because if my targets are in any of these availability zones, my load balancer will be able to send the request to these targets. Okay, so now I can actually select all my availability zones. In case if I have my third availability zone, I can also select my third availability zone. Okay, that's not a problem. I can just do AP South 1A, AP South 1B, right? Because right now I don't have subnets in my South 1C. But if I create a new subnet in my South 1C, let me do that. Let me go to my VPC. So till now you have been only using two subnets, right? 1A, 1B, or two availability zones, 1A, 1B. So now let me just go ahead and add a third subnet, which says subnet 3. Just subnet 3 and availability zone is 1C. Okay, and what is the IP address range that I can give? 10.0.30/24. Okay, 10.0.30/24. It's subnet 3. Just go ahead and create subnet. It's perfect. So it's created. Subnet 3 is also created. So I have 3 subnets right now. So it's spanning across 3 availability zones. So let me just go back to my load balancer and let me just refresh this. I'll just select my VPC. Yeah, you will get the third subnet also because you will get the third availability zone as well. Okay, so now what I can do is I can select all the 3 subnets if I want. Okay, if I want, I can select all the 3 subnets. So that way, my load balancer will have it's spread across all the 3 availability zones, right? It's basically going to be an overarching thing, which is going to sit on top of all my 3 availability zones, and it's going to send the traffic to the targets which are across all these 3 availability zones, right? But in this case, since I'm creating an internet facing load balancer, I need to have at least one, I need to select one subnet which is present in the public subnet, which has an internet gateway facing, right? So that's the reason you will see this small message coming here. The subnet for your internet facing load balancer must have a route to an internet gateway. You can update it. Okay, that's fine. That's okay. So you can just go ahead and select one of the, in this case, my South 1A, where I have a subnet 1, which is my public subnet. Correct? This is South 1A. This is a public subnet because it has got a route. It has got a route to my internet gateway. Whereas the other subnets don't have route to an internet gateway. Like subnet 3 and 2 does not have a route to an internet gateway. This is an NAT gateway. Don't get confused with NAT gateway. NAT gateway is just for egress, not for ingress, right? But for ingress, you need a internet gateway. Okay, all right. So let's come back. So now I've selected all the 3 availability zones so that I can have a better availability of my applications. Then you have to select a security group for your application load balancer. Okay, because application load balancer, as I said, is similar to what an EC2 instance is, right? So because now when you provision an EC2 instance, you need to give some security group to your EC2 instance, correct? So now you can go and either create a new security group or select an existing one. I'll just go ahead and create a new one. I'll just say my ALB SG. Just say my ALB security group, and it stays in this. Inbound rules are, let me just say HTTP. I'll only allow HTTP, HTTPS, right? HTTP port 80 from 0000. And I'll allow HTTPS as well. In case if I install a certificate, 0000, just 480 and 443, I'll just save and create an outbound. I'll just allow all traffic. Just create this. Perfect. I'll come back, just refresh this, and I'll just select my ALB security group. This is the security group. I'm going to remove the default. So this is the security group I'm attaching to my load balancer. That way, it will allow only 80 and 443. It won't allow other traffic to come through. Okay, when it comes through the internet gateway. Okay, and okay, so now you got to have some sort of a target group, but we'll come back to that. Okay, for now, let's just create a blank load balancer, but it will need some target group. So let me just go ahead and create a new target group. Okay, so now target group is something where, so now you have, if I go back to my this thing. So this is the load balancer. So now what I need to do is I need to actually create a new target group. That says the target group will have, okay, so this is my target group. So target group will have these 2 targets. Targets are nothing but the actual backend nodes, correct? So these are the 2 targets that I'm going to allocate to this target group. And for this target group, I will create certain rules, right? So similar to this, you can have multiple target groups, right? So you want to reuse the same application load balancer for multiple applications. You can then create multiple target groups for each application, each having 2 web servers in it, and you'll be able to route the traffic according to rules that you specify. So that's the target group that we're talking about here. Okay, in this case, it's going to be, I'll just say my app target group TG, right? I'm just going to give, and it's also going to listen on port 80. It's going to be on my VPC. Okay, so now somebody was asking about health checks, correct? Earlier. Okay, so now in this target group, I will specify some sort of a health check, right? The health check is nothing but the load balancer will basically will need to understand which target is healthy so that it can route the traffic to that particular healthy target, right? Like going back to the same topic of 10 people who are decorating a function hall, right? Now assume out of that, one of them got sick, correct? Suddenly he had some sort of a giddiness and he's not well, right? I mean, the manager should not allocate any tasks to him, right? So because he's already sick, right? He can't, he's down. So manager should know about it, right? So now similarly, the load balancer will also know that, you know, a load balancer, a particular target in the target group is unhealthy. So now it does some sort of a health checks on that particular node, right? The health checks are done in such a way that there is a path. If it is a web server, you can actually continuously ping a certain path on the particular web server. For example, if it is the login page, you can continuously ping the login page and see if you're getting the HTTP response 200. If you don't get an HTTP response 200, then you call it an unhealthy host. Now, how frequent you have to do that? So you can actually, every 30 seconds you check, right? Every 30 seconds you go ahead and check, or you can change this. It can be anywhere between 5 to 300 seconds, right? I'm just going to make it the minimum. So what it does is it checks every 5 seconds. It pings that particular path, which is slash. Probably the slash is nothing but your root of your website, right? Which will basically return your login page or whatever it is, right? The home page or whatever it is. Unauthenticated. It has to be unauthenticated, correct? So once you get that, so then it means that your website is healthy, right? And then it also checks it, the number of consecutive health checks required before considering an unhealthy target, right? Now, if it fails continuously for five times, it checks every 5 seconds, and after 25 seconds, right, which is about 5 checks. After 5 checks, if it fails, then it will consider it to be unhealthy. So in this case, what we'll do is we'll just make it 3. Okay, after 3 checks, which means that after 15 seconds, if my website goes down and it checks every 5 seconds, and after 15 seconds, 5 3s are 15, after 15 seconds, it will consider it to be unhealthy. The number of consecutive health check successes required before considering, and okay, this is the success, this is the failure, this is the healthy threshold. Okay, it has to consider a particular target as a healthy if it succeeds consecutively for 3 times. Okay, and if it fails consecutively for 2 times, then it is unhealthy. Okay, this is the opposite. This is healthy, this is unhealthy. Okay, and if the if the target does not respond at all, right, it gives a timeout, then wait for 5 seconds, and if it times out, then consider it to be unhealthy. It's a failed health check. That's what it means. Okay, and success code you're looking for is 200. It has to be an HTTP success code. It has to be 200, or sometimes it is 200 to 299. You can also give a range here, 200 to 299. Okay, so that's what I'm doing. So let me just go ahead and create this, and you can create, you can use the protocol versions of HTTP1, HTTP2, or gRPC. gRPC is again another protocol that is commonly used these days to build applications. So let me just go ahead and add next. Okay, health checks must be smaller than the interval. Okay, the interval is 5 seconds, right? Okay, this I'll just make it 3 seconds. So then you come and register targets. Now, for now, we'll not register any targets because I don't have any targets. I have not created any EC2 instances right now. Okay, I've just created a target group. So now let me come back to my load balancer and refresh this. And I will get my target group. I'll assign this target group to the load balancer, which is my app-target group to the load balancer. Okay, and I can add more listeners. So each one is called a listener, right? So in this case, this particular application is listening on port 80. I can have another application listening on port 443 as well, on port 443 or HTTP port 8080, right? So that is also possible. Okay, it's listening on any other port, right, other than 80. That is also possible. But anyways, let me just remove this. So this is listening on port 80, and it's going to forward the traffic to this particular target group. So the load balancer will be listening on port 80 on that particular public IP address. So the moment the traffic hits that, it is going to simply forward the traffic to this particular target group called my app target group. And what is that target group containing? It is also listening on, it is containing multiple targets. Right now there are no targets registered, but once we create those targets and once we register, it will have multiple targets, which are nothing but EC2 instances, which are also listening on port 80 on HTTP. Okay, with a health checks of so and so configurations, which is basically listening on slash. slash is the root of your web server, correct? When you just simply hit the IP address, you return some page, correct? That is the health check page. And these are the configurations that I'm going to use to complete my health checks. So that way, every 5 seconds, the load balancer is going to ping this particular path and wait for a response between 200 to 299. If it responds with one of these HTTP success codes of 200 to 299, then it will wait for 3 consecutive healthy check successes to call that particular node as healthy. But if it fails 2 consecutive times, then it will call that as unhealthy. Okay, that's the way this health checks work, right? So somebody was asking about the health checks. Does this answer your question?
Yep.
Okay, perfect. All right. Okay, now let's come back. Okay, this is a listener that I've created, and this is the summary. So let me just go ahead and create the load balancer, right? So let me just go ahead on create load balancer. So now you have successfully created the load balancer, and now let me just go. So it will see the state as provisioning, and this will be across 3 availability zones: availability zone 1A, 1B, and 1C. This is of type application. And if I expand this a little, this is the description of this load balancer. And since I've provisioned this on an internet facing, and I've selected one subnet which is having a public subnet, which is having an internet gateway routable IP address. So that's the through the virtue of that, it will get an IP address allocated to it, a public IP address allocated to it. But again, the public IP address will keep changing for this load balancer, because for ALB, you won't get a static public IP address. Okay. What the load balancer does is it keeps changing the IP address of this load balancer, but the DNS name, this is the DNS name, which is not going to change, right? So now if you see my ALB hyphen whatever .ap south1.elb.amazonaws.com, this DNS name is not going to change. So now when I access my application, it will be through this DNS name. And now when I want to assign a domain name, I will actually use this DNS name, and I'll create a CNAME in my domain, record management, and I will assign my domain name to this particular DNS name of the load balancer. So you will never use the IP address of your load balancer, okay? Because the IP address of your load balancer keeps changing because it's elastic in nature. And when AWS adds more nodes to my load balancer, in order to scale my load balancer, some of the IP addresses might change. Okay, and it has got one listener, which is listening on port 80, and which is actually forwarding the traffic to my app target group, and that my app target group contains, if I open my app target group, it has no targets registered, okay, because I have not created any EC2 instances and no targets are registered. So now, as of now, I just created a load balancer with no targets registered. So now if I go ahead and, is it provisioned? Let me just go ahead and refresh it. Yes, it's active now. So what I can do is I can just go copy this domain name, and let me just open a new browser window and hit enter. It will just give me an error. It says 503, right? Which is, there's nothing available for my load balancer to serve the traffic on, because I have not created any. Now, going back to that example of manager who is taking the help of 10 people to decorate the function hall. He doesn't have anyone at his disposal right now, right? If he gets 10 items to get decorated, he will simply have those items, right? Or rather, he will reject those items, saying that I don't have anyone to, go ahead and start the decoration work. So that's what this means. Okay, so now let me just go back. Okay, so now let's go back, and load balancer is ready. If I go back to my diagram, the load balancer is ready, the target group is ready, but I don't have these two, right? So these two are not provisioned right now. So now we are going to provision these two. Okay, let's go ahead and provision 2 EC2 instances. Okay, and what we're going to do is we're actually going to provision that in a subnet in availability zone 2 and availability zone 3. Remember, we also created a new availability zone. we also added a new availability zone to our architecture, right? So let me just extend this a bit, and let me extend my VPC box a bit. Okay, and what I'm going to do is I'm just going to take this availability zone to make this AZ3. Okay, this is a new availability zone that I've just added to my architecture, right? Earlier it was not there because I never had a subnet in AZ3. I just created a new subnet in my AZ3 called subnet 3, which has 10.0/3.0/24. Okay, so now what I'm going to do is I have my target group which is created. Okay, so now my target group can actually extend to across availability zones. What I'm going to do is I'm just going to create 2 EC2 instances. Okay, so one in subnet 2, the other one in subnet 3. Okay, and my load balancer is actually going to send the traffic to both these subnets, right? So subnet 2, EC2 instance which is in subnet 2, EC2 instance which is in subnet 3. Okay, and my load balancer itself is publicly routable. There is a DNS name associated with my load balancer. What is the DNS name of my load balancer? This guy. Okay, this is my DNS name of my load balancer. So now any request that comes, it will come hit this DNS, and load balancer will receive it. And this is my target group. What is the target group name? Is my app -target group. That's the name of my target group. This is the name of my target group. It's actually going to send it to my target group, and my load balancer is listening on port 80. Port 80, HTTP port 80. That is what it is listening on, correct? This is what it's actually listening on. And even my target group also has got EC2 instances which are listening on HTTP port 80. They're also listening on HTTP port 80. And we'll actually, what we'll do is we'll make one of them unhealthy and see how the load balancer responds to that, right? Okay, let's quickly jump into action. I'm just going to go create these 2 EC2 instances in these 2 availability zones. Okay, let me just go to my EC2 instance. Let me launch a new instance. Amazon Linux. I'm going to provision t2.micro. Okay, the first instance that I'll provision is in my subnet 2. Okay, it does not have a public IP address, but I can still log into that, right, using a jump host. We'll create the jump host later. Okay, I'll first create one in subnet 2 with the default settings, tagged as name my web server 1 is the name that I'm giving. Security group. I'm just going to create a new security group and reuse that security group across. It has SSH, it has HTTP because it needs to allow traffic, right? HTTP, and that HTTP has to come from, I'm going to allow the traffic to flow only between load balancer and my EC2 instance, right? I'm not going to allow anyone else to hit my EC2 instance on HTTP. So that way, what I'm going to do is I'm just going to say security group. My load balancer security group is this, right? So only my load balancers. So this is called self-referential security groups, right? In fact, I didn't tell you about this when we spoke about security groups. So now what you can do is you can use something called the self-referential security groups. What it means is, so now I have my security group, which I created for my load balancer, right? So in this case, this is my load balancer and I have a security group. So now I can restrict the traffic coming to my EC2 instances by saying that it should allow port 80, which is HTTP TCP port 80, coming only from this particular security group. And this security group belongs to the load balancers. That way, I'm restricting 80 to come only from load balancer. The 80 can't be accepted from anywhere outside. So this way, I'm only restricting my traffic to come only from my load balancer, and I'm not allowing any user to bypass the load balancer and hit the web server directly. Okay, so that's what I'm trying to do out here, right? So because usually what people do is, people are smart, right? So they don't want to hit the load balancer. If they know the IP address of the web server, they can hit 80 on the IP address of the web server and they can directly hit, and they can also misuse it, right? So I don't want people to do that. I want people to just come through load balancer each and every time. I don't want them to, even if somebody tries to hit my web server on port 80 from a different source, it's not going to allow, because my security group will prevent them from doing that. Okay, so I'm just going to say my web app SG, right? So that's the name of the security group that I'm going to give. Review and launch, and I'm going to use my PEM file. I acknowledge, launch. Okay, the first instance is coming up. I'll also create a second instance in subnet 3. Configure instance details. Subnet 3, yes, I'm going to use subnet 3 here. Next, add storage, add tags, name my web server 2, configure security group. I will just reuse the same security group that I just created. My web app security group. Okay. Next, review and launch. Use the same PEM file, acknowledge, launch instance. Okay, so there is a availability zone restriction, correct? Okay, so let me use a different. I'm not going to use t2.micro. Let me use different t-shirt size for that. That's okay. I'm not going to use t2.micro. I will use like t2.large, because it looks like this got exhausted in availability zone 3. Sometimes that also happens, right? So a specific t-shirt size is exhausted. Acknowledge, launch. Okay, maybe T itself is not available. Let me just go and make it some other R or C or M. Okay, c5.large.
Okay.
Let me just go ahead and use c5.large. Sorry?
It may be subnet problem, sir. Subnet,
No, it's not a subnet problem. It is basically a limitation with the availability zone. Availability zone 3 has got certain limitations. That's the problem. Subnet has nothing in it, right? So now it's working. T2 is not supported in availability zone 3. Okay, so you guys don't have to do this. Okay, I mean, you guys don't have to create a c5.large, because you'll get charged. Okay, don't do that. I'm just showing it so that you understand it, but you necessarily don't have to do this. Okay, this is done. So now I'm going to go and say create a t2.micro. I'll create a jump host, right? Because I need to install the web server on those 2 servers, correct? So let me use subnet 1, which is my public subnet, which has the auto-assign public IP enabled. Add storage, add tags, name. I'm just going to say jump host or jump server. Next, configure security group. I will reuse an existing public security group, public SSH. Yeah, I'm going to use this. No, I'm not this. Wait. Yeah, I use this, which allows 0000. Launch. I will use pair PEM launch instances. Okay, so jump server, let it come up. So once the jump server comes up, so then what I'm going to do is, okay, in the meantime, I also need to change my subnet 3. Right now, subnet 2 has got a route going through my NAT gateway, but subnet 3 doesn't have. So for my subnet 3, for my route table, I need to go and okay, for my subnet 3, right, I'll just go ahead and change the route table, edit route table association. I will use my private route table, which has my NAT gateway. I'll just save it. Okay, so now my subnet 3 is also has internet access, so that I can download the HTTPD packages and install it. Okay, both my subnet 2 and subnet 3 has got NAT gateway associated with it, so that it can have internet access, egress internet access, not ingress. Okay, I'm just going to go refresh. Okay, now I think jump server is ready. Let me first log into my jump server. I'll use my terminal. In your case, Windows users will use PuTTY, Linux users will use your inbuilt terminals. Okay. Downloads. Okay. So search. Yes. Okay, this is done. So now what I need to do is I need to create a mykppem.pem. I'll just create a new file, or I can also copy it from my this thing using SCP, correct? I'll just do that. That's better. Okay. I'm just going to copy it there. So I'll change the IP address of it to my public EC2 instance. Yeah, it's copied. So now let me just SSH into that. Yeah, copied. So it has the right permissions. So now let me jump from my public to my private, okay, which is this one, right? So see, this doesn't have a public IP address. It only has a private IP address, 10.02.250 and 10.03.121. Okay, so let me just go SSH -i IKP. EC2-user@. Yeah. Okay, I'm right now in my EC2 instance 1, which is this guy. I'm right now here. First, let me install HTTPD sudo su. Let me just elevate myself, and then let me say yum update -y, just to ensure that it has all the latest packages in it. Okay, wait, let me just check. Okay, is there a problem with my internet route? Let me just cross check that quickly. Is my NAT gateway running? Just go to oops, I don't have a NAT gateway at all. I think I deleted my NAT gateway. Okay, let me just go ahead and create my NAT gateway. So, okay, so if I go to my private route table, you will see a black hole route. Okay, got it. So let me just go create an NAT gateway. I was assuming that it was there. Sorry about that. I will just say NAT gateway subnet 1 public. Just allocate a new EAP. Yeah, that's it. So create an NAT gateway. Okay, got it. So it's created. Yeah, so let's let it create. Just give it a few seconds for this to become active. Then we'll go and modify the route table. So right now my main route table doesn't have anything. Public route table has subnet 1, okay, which is public subnet. The remaining 2 subnets, which belongs to AZ2 and AZ3, are with respect to my private route table. So I'm just going to go tables on the private route table. Just edit the routes, and I will just remove this. Select the NAT gateway. Let's see. Yeah, it's come. So let me just save this. Yeah, so it's active. So now let me just check my NAT gateway. Is it up and running? It is still pending, but let's just wait for a few seconds. It should come up. Now, if I go back to my EC2 instance, okay, so if you see this, the reason why I got a doubt was that it took some time to update, correct? So it said connection timed out, which means that the EC2 instance doesn't have a internet connectivity. See, these are some of the troubleshooting techniques that you'll have to learn, right? I mean, how do you troubleshoot if you're doing something assuming that it'll be in place, but it doesn't work? Where do you look for? It's very important. In fact, let's do a exclusive session on troubleshooting skills, right? I'll prepare a few scenarios and I'm going to ask a few of you or most of you to troubleshoot it and tell me what the issue is, right? Okay, let's see if it's, yeah, it's available. So now let's just to confirm, I'll just say curl google.com, right? I mean, I didn't do this earlier. Yeah, now it's working. So now let's do one thing. Let's just go ahead and yum update y. Yeah, so now it has internet access. Yeah, now let me install yum install httpd-y. Yes, that's done. Sudo service httpd start. Just started it. Let me just go to cd/etc where www, right? cd html. I'm just going to create a new file out here called nano index.html. I'll just say html h1. This request is from web server 1, right? I'm just going to do that h1/html, right? So Control X, yes. Okay, so this is done. So it should start serving it. So let me come out of this. Okay, so now if I say curl http://10.0.2.250. Yeah, so you get this, right? You get this request is from web server 1. Okay, just come out of it. And then let me log into the other EC2 instance. That's it. Let me go to the other EC2 instance, which is 3.121. 121. Yeah. So let's quickly check if this guy has got internet access. Curl google.com. Yes, it has internet access. Just do sudo su yum update -y. Okay, that's done. Now I'll just do install httpd-y. Yeah, httpd is installed. And let me say service httpd start, service httpd status. Yeah, that's okay, that's fine. Let me just go to cd/var www.html and let me say nano index.html. Okay, let's just do the same html h1. This web page is served from web server 2/h1/html. Okay, just save it, come out of it. So now just do curl http://10.0.3.121. Fail to connect. Okay.
Sorry, HTTPD, no, sir.
Oh, sorry, HTTPD. Sorry. Yeah, got it. Thanks for that. Okay, it's running. Okay, so now let me just do a curl. It's working, right? Okay, cool. So now both the web servers are up and running. I've got these two web servers ready. So one is serving a HTML page called this web server. This page is being served from web server 1. This page is being served from web server 2. Okay, now let me go back to my load balancer. I'm going to close everything. Just close everything, close everything. Okay. Now I'm going to go to my target groups. Okay, go to my EC2 load balancers and target groups. This is my target group. So now what I'm going to do is right now there are 0 healthy instances, 0 unhealthy instances, right? And 0 total targets. Now you can register targets out here. So just click on this register targets. So now you will have all the EC2 instances running in this account, right? So now these are the 2 EC2 instances that I want to register as targets. So select web server 1, web server 2, and include as pending below. Click on that. And the ports are port 80. So once it is, you see here, you review this and then just say register pending targets. Okay. So now it's going to register it, okay, using the health check configurations that we have given. Okay, in a while you should see that it will turn into healthy, right? Because the health check says that you will have healthy threshold of 3 consecutive health check successes, which means that every 5 seconds it's going to check for the curl on the slash, and then it will return that web page, and then if it succeeds for 15 seconds for 3 consecutive health checks, then it's going to make it healthy. Let's just wait for it to turn healthy. Yeah, if you see, it has turned healthy right now because it is able to respond back on the slash. What is slash? Slash is nothing but you have this thing, right? I just did a curl, correct? This is the slash, which is the root of my web server, which is just the IP address of the web server. So that is where my index.html is running, correct? It's able to respond back with status 200. This is status 200, correct? If you want to know what is the status, see, it's giving a status 200. Okay. Okay. So now let me go back to my load balancer. So this is running. So these two are working. So now if I go to my load balancer, okay. So this is the load balancer that I have with this as my DNS. What I can do is I can just go ahead and browse this. I can just simply paste my DNS entry. Yeah, see, this request is from web server 2, right? So because now what the load balancer did was it took the request, it first sent the first request to this guy. So now if I refresh this, see, the next time it is actually sending it to web server 2. This request is served from web server 2. Now, if I keep refreshing, it will alternate between web server 1 and web server 2. See this. Each request it is sending it to web server 1, the other request it is sending it to the web server 2. That's how my load balancer is working. Okay, I won't be able to access my EC2 instance directly, right? I mean, my private IP address of my EC2 instance is routable only within the VPC. It's not routable to the external world. But from the external world, I can actually give you this, right? So you also try this. Just say this, paste it. Yeah, you can also try this URL and try accessing it. It'll, I mean, now since many of you are going to access it, the request is going to originate from multiple users. So you will see a slightly different behavior of it'll, for a few requests, it will be web server 1. For a few requests, it will be web server 2. It depends on the cumulative traffic that is hitting the load balancer. Okay, you can try this out. Okay, so that's an important topic on application load balancers. Okay, so now what I'm going to do is I'm just going to give you, I'm not sure if I have an assignment for you on specifically on load balancer. If not, what you can do is I'll just point you to something which you can learn and you can do a small assignment. Okay. I'm sorry, I don't have an assignment documented for today, but I'm going to point you to some quick start sessions which you can actually use it. Okay, just give me a second. I'm just searching for that. Like what you did yesterday, no, on the yeah. Okay. I'm just going to give you this. I'm pinging you this URL in the chat. Please follow these steps, okay? And you'll be able to repeat whatever I did, okay? But in this case, I mean, you just have to ensure that you set up your HTTPD server, right? You all know about it, how to set up a HTTPD server. It is documented in one of the old lab assignments. So you can just go ahead and use that. Okay. But anyways, don't worry if you're not able to complete this, because this is only one part of the whole puzzle. I'm going to teach you about auto scaling. And then I'm actually going to give you a comprehensive guide to do your project. So when you do your project, you're actually going to do all of these. Whatever I did today, all of this you're going to do. If you're able to follow based on today's video and based on the link I have just given you, please do that. Otherwise, in case if you think that you need more guidance and you need a step-by-step instructions, please wait for the project, which you're going to do in a couple of days from now. Okay. So with that, let me just take a leave. One quick thing that I wanted to just make a small announcement is, if you can actually create your own resumes, right? I mean, whoever has got resumes created and whoever is in the process of creating your resumes, so please create your resumes, right? And we're going to do a special session on Sunday to review your resumes and give you some best practices on how to build resumes and how to capture the right detailed skills in your resumes, right? So which will actually help you with your job finding exercise. Okay. So if for those who of you have not started building your resumes, start building it from today. And we're going to do a special session on Sunday to review those and refine those. And I'm going to give you some best practices in terms of what should you capture and what level of details that you should capture. Okay, so so with that, let me just take a leave, right? And please get into your breakout rooms. And tomorrow we're going to learn about auto scaling. Auto scaling is another important topic in continuation to what we learned today, right? I mean, these are all step-by-step build up for the actual project. Okay, so I'll see you all tomorrow. So have a great day. Thanks everyone. Sai Ram, Sai Krishna, Sai Ram Mentors. Thank you. See you all tomorrow.